Hello friends, my name is Lalit Soni and you are watching State PCS Quick Revision by Drishti PCS. In this episode of Geography section, we will be talking about the ocean currents. We will be looking at what are ocean currents, what are the factors which are influencing them. We will be seeing major kinds or the types of these ocean currents, that is warm ocean currents or the cold ocean currents. Other than that, we will be talking about the surface ocean currents. We will be talking about the deep water ocean currents. All these factors will be discussed today in this section. These are important because direct questions has been asked in various examinations, be it PCS or the UPSC. Questions has been asked directly on the nature of the currents or the factors which are, you can say, influencing these currents. Okay, so let's start our discussion with the definition of the ocean currents, or we will be seeing that what ocean currents are. Okay, now let's see if you have ever observed that there are various rivers which are there on the continents and they are flowing in a particular direction because of the geography. Okay, similarly in oceans also, wherein you will be find a rather calm ocean, you will also find that there are certain bands of water which are moving continuously. Now these bands of water are moving with respect to your wind direction, or there are various other factors like temperature, salinity, etc., which are responsible for this particular movement. Now these bands of flowing water in the oceans are called as ocean currents. Okay, now let's see. Ocean currents are like the river flow in the oceans. They represents a regular volume of water in a definite path and direction. You will be seeing that they are moving in a particular path and in a particular direction. Okay, now what are the factors which are influencing these currents of the water? That is basically your primary factors and the secondary factors. That has been divided in two types. That is, one is your primary forces, second is your secondary forces. When we are talking about the primary forces or the primary factors, these are the factors which are basically initiating the movement. These are starting the movement, or they are responsible for the origin of their movement. Okay, then secondary forces or the secondary factors, these are, you can say, responsible for the currents to flow or their direction, their speed. For that, these are responsible. So we will be talking about them one by one. Over here you can see this is a map wherein various ocean currents are given. The blue ones are your cold ocean currents and the red ones are your, you can say, warm ocean currents. Now you will be seeing that a particular name of a current is given. Let's say we are talking about the Peru current. Now Peru current is having one particular direction. It will not be changed until unless something drastic happens in the climate, or you can say long term positioning of continents, etc. So until unless this direction will be like this. Okay, so that is why we have said that over here that they are having a definite path and a definite direction. Okay, so here are various currents which are there. We'll be talking about them in further in the slides. Now looking at the primary forces. Now what are the primary forces which are responsible for the origin of the currents? One is your solar energy. Now you know that when we talk about a particular matter or a particular substance, we know that when you heat them, okay, when you heat them, this will expand. Okay, similarly when we are talking about the ocean water also, basically on getting heat from sun, they will also expand. Okay, if they are expanding, that means that the volume is expanding. Okay, so at a particular point when this volume is expansive, so the sea level will rise. Okay, so by the heating or by heating by the solar energy causes the water to expand, because of which there will be, you can say, change in the level of the sea. That is, around the equator you will be seeing that 8 centimeter higher levels are there. Okay, so you can see why, because why on the equator? Because obviously when we are talking about, this is your earth, this is your equator. Okay, sun is something like over here, and sun is moving in this particular pattern between Tropic of Cancer and Capricorn. Okay, so this is the positioning of sun. So this is the area which is getting the most heat throughout the year. That is why the equators are the warmest places, and that is why water here will be expanding more. Okay, because of the expansion, the sea level of the water will rise by 8 centimeter, because of which, since volume is very much, so you will be seeing that, let's say this is basically your water at the equator. Okay, and because of the level is rising, so you will be seeing that it is rising like this, and this is your 8 centimeter rise, because of which there is a bulge which has been created. Now there are slopes on which this water will flow. Now the flow of water which is starting from this particular place to towards this particular place, that is basically one of your ocean current. Okay, so water will tend to flow down the slope. That is one thing that is initiating the water flow over here. Second is your wind. When, let's say, this is your surface. Okay, Now this is your surface of the ocean, and there is a wind which is blowing in this particular direction. Now when wind is blowing in this particular direction, some part will also be touching the ocean surface, so they will drag the ocean surface in this direction. So now this particular water will start to move in this direction. So in the upper layers of the ocean, you will be seeing that winds are having an impact on their direction and ultimately causing a movement in the direction of the wind. Okay, so wind blowing on the surface of the ocean pushes the water to move. Friction between the water and the water surface affects the movement of the water body in this course. Now again, this is the initiation of the ocean current. Okay, then comes the gravity. Because of the gravity, obviously, if there is a water pile which is there and gravity is acting upon this, let's say this is the water pile which is there because of the expansion. Now what is happening over here? Water flowing down the slope, that is basically gravity acting over here. Okay, so gravity is another factor. Other than that, one more factor is that there is your Coriolis force. Okay, because of the rotation of the earth, there is a pseudo force which is working, that is Coriolis force. Okay, let's see, I'll tell you. This is your earth. Okay, this is equator, and you are here in the southern hemisphere. Okay, now you know that earth is moving in this particular direction. Okay, earth is moving from your west to east. Now you have thrown a ball over here. Okay, and you are targeting this particular spot at the equator, but earth is moving from west to east. So by the time this ball reaches over here, you will be seeing that this spot has shifted to this place because earth was moving. So basically what is happening is that you were targeting this particular thing, but you have hit this. Okay, so ultimately you will be seeing that your target was like this, but you have hit this. That means that you have shifted towards the left in the southern hemisphere. So basically there is a tendency, if you are throwing an object in the southern hemisphere towards the equator, that will tend to move in the left direction. Okay, so this particular effect is called as the Coriolis effect. Okay, on the other hand, if we talk about the northern hemisphere, you will be seeing that movement will be in the right direction. Okay, so let's see. The Coriolis force intervenes and causes the water to move to the right in the northern hemisphere and to the left in the southern hemisphere. So here you can see the object reflects to the right in the northern hemisphere. See, this is the object which is reflecting right in the northern hemisphere, and then the second one, when we are talking about the southern hemisphere, it will reflect towards the left. Okay, so I hope that is clear. Just know that in the northern hemisphere, if you are throwing a ball, that will deflect in the right direction, and if you are throwing a ball in the southern hemisphere, that will deflect toward the left direction. Okay, now because of which, let's see, there is this you can say water which is still water is there, and because of the wind they are trying to push the water, and because of the Coriolis force also, water will tend to move because of the pseudo effect. Okay, now this is the third factor, which was your Coriolis force. So primary factors are heating, wind, gravity, Coriolis force. Okay, now they are talking about one thing, that is gyre. Now large accumulation of water and the flow around them is called the gyres. Okay, so in this particular picture you can see, now this is the large body of water. There is a water which is flowing over here. Okay, and they are particularly flowing in a particular direction. Now you will be seeing that this is going like this. Let's see the clear picture over here. This is going like this, the next drift is going like this, this is going like this. Okay, ultimately you will be seeing that they are forming a movement like this. Now this movement is called as gyre. Here you will be seeing that this is going like this, so there will be this movement. So these are called as gyres. These are the accumulations which are called as gyres basically. Okay, now moving to the next part, that is basically secondary forces. Now secondary forces are the one which are basically, you can say, influencing the intensity over here. Difference in the water density. Now if a dense water is there, that will have the tendency to sink. Dense means heavy. Okay, and if something is heavy, that will sink. Now when we are talking about your cold versus hot water, cold versus hot or warm water, so you will be seeing that when we are cooling the water, so what is happening is that the molecules of the water, they are coming closer to each other. Let's say this is your container, and if you are freezing it, so the molecules of water will come closer with each other and they will form a solid unit, that is your ice. So that means that the density in the ice will be more. That is why if you are decreasing the temperature, density will increase, and if you are increasing the temperature, density will decrease. Okay, so that is one thing you can remember. If your temperature is increasing, that means that density is decreasing. Now if density is decreasing, that means that water will rise up, and if there is a cold water, because density is high, then it will go for the sinking. Okay, so that is something. Other than that, when we are talking about salinity also is there. If there is a higher salinity, that means that water will be dense, and that is why it will sink. And if there is lower salinity, water will be, you can say, less dense, and that is why it will not go for the sinking. Okay, so these are two factors, temperature and the salinity, which are, basically impacting your density, and ultimately that will cause water to rise or sink. Okay, so that is there, dense water tends to sink and relatively lighter water tends to rise. Okay, so that is your vertical mobility of, you can say, water in the oceans. Moving further, temperature of water, we have already discussed that if there is water which is cold, that means that density is high, and that is why it will sink. So cold water always sinks, warm water will always rise. Okay, so that is there. So if we are at poles, okay, now poles water is cold, that means that cold water will sink. Okay, so cold water which is sinking, and then it will going to the equator side, because it is, it has sinking, and then it will be moving towards the equator side, and that particular deep water circulation will be called as the deep water currents. Okay, now what are the type of the currents? One is your surface currents, which we have already seen. These are your surface currents which are there because of the winds effect. Okay, and then second is your deep water currents, that is because of, definitely because of your temperature and the salinity. Okay, which is there. So here you can see in this particular picture, these are your deep water circulations which are there because of the temperature difference and the salinity. Okay, so there are two type of currents which are there, surface currents, and these surface currents are further divided into two parts, that is your warm ocean currents and your cold ocean currents. Okay, so we'll be talking about that. Similarly, deep waters are also divided, that is, one will be your warm, you can say, belt, and the second will be your cold belt. Okay, so now let's move further to the next one, that is surface currents. Now when we are talking about the surface currents, this will be impacted by the global winds. Let's say when we are talking about the easterlies, westerlies, so with the direction of the winds, the particular current will go. Okay, large scale surface oceans are driven by the global winds systems that are fueled by the energy from the sun. Now these currents transfers heat from tropics to the polar regions, because equator is the place which is the hottest one. Okay, and these are basically fueled by the sun's solar energy, because of which water is expanding, and then the process is initiated. So now this is initiated at the equator, and that is why they will be moving towards the pole. Okay, it constitutes 10% of the ocean currents. Okay, now moving further, deep water currents, we have seen that water density plays an important role, water temperature plays an important role. So you will be seeing that from poles, the cold water will be moving towards the equator. Okay, and the hot water from the equator, that will be moving towards the pole. Difference in the water density resulting from the variability of the temperature, that is thermo, and salinity, that is haline. So these are basically your thermohaline belts. Okay, and also cause ocean currents. This process is called as the thermohaline circulations. So please remember this particular fact, that is thermohaline circulations. It makes up of for the 90% of the ocean water. We have seen that the surface currents are only 10%. So rest is your thermohaline circulation. And now these thermohaline circulations are mostly responsible for the water life, or the, you can say, marine ecosystem. Okay, these water moves around the ocean basins due to the variation in the density and the gravity. Deep waters sink into deep ocean basins at the high latitude, whereas the temperature are cold enough to cause the density to increase. Now density is increased due to the cold temperature, that means that will go for the sinking. Now this starts a global conveyor belt. Basically you can say that there is the combination of the deep and the surface currents which are circulating around the globe from the last thousands of years. These globes that of the ocean currents are critical part of Earth's climatic system, as well as the ocean nutrients and the carbon dioxide cycles, etc. Okay, that means that now these belts, or these ocean currents, these are basically important for your marine ecosystem as well. Okay, now moving further, here type of ocean currents, if we talk about, as I already told you, based on the temperature, there will be cold currents and there will be hot currents. Okay, now cold currents means that they will be bringing the cold water into the warm water areas. Okay, now most of the time you will be seeing that these are found on the west coast of the continent, in the low and the middle latitudes, and when we are talking about the higher latitudes, they are found in the east coast. So you can see this particular picture, we are talking about the cold ones. Okay, so on the western coast of the low and the middle continents. Okay, so this is your cold current, this is cold current, this is cold current, and this is cold current. Now when we are talking about the higher latitudes, you will be finding that The eastern coast, here you can say this is your eastern coast. Labrador, this is also eastern coast. Oyosho, this is also eastern coast. Now these are basically, you can say, your the areas where cold currents are found. That is basically in the low and the middle latitudes, that is the western coast of the continent, and in the higher latitude, that is eastern coast of the continent. Now coming to the second one, that is your warm currents. It brings warm water from cold area into the cold areas. Okay, so these are your warm currents, and you will be seeing that they are mostly found on the east coast of the continent, in the low and middle latitudes, and west coast in the high latitude, opposite of the cold currents. Here you can see this is the east coast, and here these are the west coast over here. This is the east coast over here, and obviously in the higher latitude there is nothing. So mostly you will be finding that the warm currents are on the eastern coast of the low and the middle latitudes, and the western coast of the higher latitudes. Okay, I hope that is clear. Now we can move further. Now this is the picture which becomes important for you, because in this particular picture mostly all of the important currents are given. Okay, so I'll go through them one by one. We have this north equatorial current. We have seen that on the equator water will bulge, and then ultimately that will start to flow because of the gravity. So that is one thing, north equatorial current and southern equatorial current. And how these are happening? Because see, north is going over here, water will accumulate over here, and because of which there will be a south equatorial current as well. Second is your Brazil current. Brazil current is also a, you can say, warm current, because from the equator water is coming. That means that equator has warm water. It will be going towards the poles. Okay, here we have agulas. Agulas are basically starting from the equator and moving towards the poles. Okay, this Brazil current is in the vicinity of the eastern coast of the American continent, South American continent, and this is on the eastern coast of the African continent. Okay, here you can say East Australian coast, that is also a warm current. Okay, and when we are talking about the Gulf Stream over here and the North Atlantic Drift, these are also on the eastern coast, and these are all warm currents because they are originating somewhere from the equator or the tropical region, and then they are moving towards the pole. Okay, now these are the important warm currents. Other than that, we have North Pacific current, Gulf Stream, North Atlantic Drift, North Equatorial Current, South Equatorial Current, Brazil Current, Agulhas Current. We have Leeuwin Current, we have East Australian Current, Kuroshio. These are all warm currents. Now coming to the cold currents, you will be seeing that these are starting from the poles and moving towards the equator. Here we will be seeing Peruvian Current. Okay, then we have Venezuela Current. Okay, other than that, we have West Australian Current. Here you will be seeing that we have a Canary Current which is coming from the poles. We have Labrador over here. Okay, we have Alaska Current, we have Oyosho currents. These are basically your cold currents. California current, these are cold currents. Okay, and when we are talking about the east wind drift and the west wind drift, these are also cold currents because of the ice caps over here. Okay, I hope that is clear. Now let's move further. Here the names are given in the Pacific Ocean, the warm currents: Kuroshio, Alaska current, Tsushima currents, then El Nino currents, North Equatorial, South Equatorial, North Pacific, Eastern Australian current, counter equatorial currents. We have talked about all these things in the last one. So cold currents in the Pacific, Humboldt, Peruvian current. Here you can see this is your Peruvian current or the Humboldt current. Next is California current. We have seen Antarctica current, Kuril current or the Oyosho current or the Okhotsk current. Okay. Then when we are talking about the Atlantic, Gulf Stream, Brazil current, Florida, Irminger, North Equatorial, South Equatorial, Equatorial counter currents. These are basically your warm currents in the Atlantic. Now cold current in the Atlantic are Canary, Venezuela, Labrador, Falkland, East Greenland, Antarctica. Okay, and when we are talking about the permanent and hot current of the Indian Ocean, so Mozambique, Agulhas, and Southern Equatorial Current, these are important for us. Then when we are talking about the permanent cold current, that is West Drift and the West Australian Current in the Indian Ocean. Okay, so these are something which you can remember for your examination. Now moving further for the practice question. Question number 1 says that the Kuroshio current flows in which ocean? That is Indian Ocean, Arctic Ocean, Pacific Ocean, or Atlantic Ocean. Moving further, which ocean current is associated with the west coast of South America? California current, Humboldt current, Gulf Stream, East Greenland current. Okay. Moving further, the Coriolis force causes ocean currents to move to the left in the northern hemisphere, to the right in the southern hemisphere, to the right in the northern hemisphere, or in a straight path. Question number 4, the primary factor that cause ocean water to expand near the equator is wind, solar energy, gravity, or Coriolis force. Next question is, which current is the cold current in Atlantic Ocean near the coast of Canada? Labrador current, Gulf Stream, California current, or Venezuela current? Okay, so these are 5 questions which are given in front of you. You have to read them, understand them, and answer them in the comment box. With that, I would like to take your leave. If you have not subscribed the channel, please subscribe it. Have a nice day.
डियर व्यूअर्स, अपने एग्जाम की तैयारी को और बेहतर करने के लिए हमारे चैनल को लाइक, शेयर और सब्सक्राइब करना न भूलें।